Many people have already stolen my thunder here. Thanks, Ed, earlier on. But as Ed mentioned, we have over 1.9 million vehicles connected globally. And that equates to over 40 billion points of data each and every day. And it's no surprise, we believe we have the richest telematics data set in the world. What I usually tell folks, and I'm sure you all know, is that we're more than just dots on a map, but clearly we have a lot of dots on a lot of maps. And through the work that Dirk's doing with the Data Accessibility Index, we will stay ahead of the curve here, and we will collect the rich engine data that we need to be able to make inferences, the accelerometer data, the GPS, and the things that you would expect us to collect. But one of the interesting things that we can do is we can turn some of these pieces of information into derivative data sets that you might not expect. And so we can take things like windshield wiper activations, harsh braking activities, and we can start to infer things like, what are the road conditions? Is there ice there? Is there some sort of missing sign because everyone's hitting their brakes hard? Can we take windshield wiper activations and globally and figure out where it's raining? And these are the types of things we're looking at. And what that does is it turns vehicles into sensors on wheels. And so more than just traffic, we're also able to do things like predict the weather and identify risky driving conditions and traffic. And so we've been able to do this in a bunch of different locations, and I've had the good privilege to go around and talk about some of this stuff in different places. For example, I did a talk with our friends at Google where we took the city of Chicago and we took our hazardous driving data. So we looked at anonymized aggregate hazardous driving data, and we combined that with weather, and we trained a model to predict what will happen in Chicago if it snows and it gets colder. What areas will become hazardous? And then I got to go to San Francisco and talk about hyperlocal weather. And if you've ever been to San Francisco, you know that you walk down one street and you're hot, and then you turn a corner and somehow it's freezing cold. So it's a really cool example of what we can do on a hyperlocal scale. And then we were working with the city of Las Vegas to figure out what can we do with traffic patterns. And I'll talk a little bit more about some of the traffic stuff we're doing on a later slide. But this is my first time ever in Portugal. And so like most people, I went online and searched about some data about Portugal. But maybe unlike most people, I searched this kind of data instead of what restaurant should I be eating at and where can I find the best tarts. And I know this might be hard to see from the back of the room, but this is actually a chart I came across from the IEA, and it ranks how fuel-efficient vehicles are in a fleet. And at the top of the list, and spoiler alert, the top of the list is not a good place to be, is Canada. And right here at the bottom of the list is Portugal, actually. And so what this means is Canada is, on average, producing 206 grams of CO2 per kilometer driven, and Portugal is producing 119. That's a pretty substantial difference. And one of the reasons, of course, is that vehicle selection matters. And so this graph here, also from the IEA, shows that in Canada, we are buying more SUVs and less cars. And it's no surprise. There's news stories in North America about manufacturers making less cars and doubling down on bigger cars, heavier cars. And of course, there's some, we're buying bigger vehicles, but it's kind of unfair. Now I'm putting my Canadian hat back on. I'm saying this isn't fair. I got off the plane in Canada. It was cold, and I came to this. So clearly this is weather related. But there's a lot of cold weather countries between Canada and Portugal on that list. And so maybe it's because we have so much space. But if that's the argument, if you're driving long distances, shouldn't your fuel economy be better? And clearly the price of fuel plays a role. And so I guess the answer here is really if there's a relationship status between a person and their vehicle, it's complicated because there's so many factors to consider. But at 1.9 million vehicles, we can really have an impact on the world if we can answer this question. How can Geotab empower their customers to make greener vehicle choices? And so this is one of the things that we're working on and one of the things that we'd like to solve for. But it's difficult. As I say, there's things that you can change and there's things that you can't. Things that we can't control necessarily are the size of the vehicle. If you're driving a Class 8 vehicle because that's what you need to do, we can't recommend a compact car. We also can't really change the driving environment. If you're in a hilly environment or a cold environment, that's not going to change. But we can benchmark you. We have the volume of data to aggregate and anonymize and benchmark against people who are in the same environments as you. But what we might be able to optimize is what fuel you drive to do what you do and what horsepower the vehicle has, for example. And so here's a kind of pretty graph of one of the examples of things that we can do. So if we want to look at driving environment, one of the proxies for how much fuel you use is how much you idle or how much you're stuck in traffic. And so we want to normalize this across different areas. We can actually measure congestion just by saying, how much time do you spend as a percentage of your total driving time going between 0 and 10 kilometers an hour, between 10 and 20, and all the way up to over 110? And this should help us sort between downtown Lisbon and here in Estoril. And we can take this benchmark, but there's way more complicated things that we need to understand. For example, what days of the week do you drive? What time of day? How far? What kind of coverage area do you need to cover? And one of the things that we've been working on for years at Geotab, for the past few years, is actually an algorithm to detect many of those things that we call vehicle vocation. And so for us, vehicle vocation is a smart way to enable benchmarks, like fuel benchmarks, to be relative to vehicles, no matter what industry they're in. So if I'm delivering a box of food or a box of parts, and it's 30 minutes or free type of deal, I should be able to learn something from that other organization. And this is a very simplistic look at what that looks like, and these graphs on the horizontal axis is hour of day, and vertical axis is day of week. And so when you look at these as a human, you can see, well, an office worker, it makes sense. They go to work in the morning, they sometimes go out for lunch, and they come home in the evening. In a delivery service, you would expect your vehicle to be busy all day. And so we make these types of features, and we train a model to understand what is the purpose of a vehicle. And if we can take that into consideration, then we can build, as Dirk says, one of these magic quadrants. And we can now start to benchmark your vehicle that you're driving in your fleet. So this is a kind of a fake fleet here that we have on the graph, and this is all the vehicles in the fleet. We can benchmark the vehicle you're in with vehicles that other people are using to do similar things in similar environments. And so if I'm in this top corner here, I'm better than all of the similar vehicles, but I'm worse than most people in the same vehicle. So what that tells me as a fleet manager is maybe there's something I can change about driver behavior or about routing. There's some other inefficiency perhaps in my fleet. And if I'm down here, it's really tough to make the decision because not only am I not on the upper end of my current vehicle, but I'm also worse than other vehicles. So again, something to inspect about the fleet. But where it starts to get interesting is in the other side of the quadrant. So if I'm in the top right corner, I'm better than most of the vehicles. I'm better than most of the people in the same vehicle, and I'm also better than most of the competition. So I've made clearly a good choice here. And if I'm on the bottom corner, then I might want to start looking at another vehicle. Again, this is optimized for fuel economy. So if we were to kind of double-click in on this vehicle here, the idea is that we would have an add-in that would show me where this vehicle sits. Now, this is in miles per gallon, I apologize, but what it's showing me is that this individual vehicle in my fictitious fleet here is kind of middle of the pack as far as Nissan Frontier trucks go. But I have 5 options below that which have better fuel economy. And I may be able to choose one of those vehicles to do the same job. And if we can make a small difference in CO2 across 1.9 million vehicles, then we can have a big impact on CO2 worldwide. And a lot of this comes down to dollars and cents, and we understand that, and so we're working on a calculator to help figure out what the ROI of changing a vehicle is, because again, it's complicated. And while we're doing all of this, we're also still doing deeper research. I'm not even going to pretend that I could explain all of the stuff that's happening here, but this is 100,000 kind of random vehicles. And what one of our data scientists has taken the initiative to do is to figure out if we can come up with a novel way of embedding vehicles into a new space where we can take 170 different features of vehicles, how they drive, their fuel economy, where they are, and put them into this kind of hyperdimensional space and visualize it. And you'll see some clusters in here, and really those clusters, that's machine learning identifying for us like vehicles. And the closest vehicles to the center of a cluster should be almost interchangeable. And so that's how we can really help by looking at an individual vehicle and at our scale have a big impact. But we've done a lot of talks as well about how we can transform a community from a smart city perspective. And we can, of course, do things with traffic and safety. And we can do other things, like Matt's going to talk about our EV suitability stuff and air quality assessments. But there was actually a report in 2017, GreenBiz and UPS report, and they asked, what are the 2 issues that most businesses care about in an urban environment? How can we make them more sustainable? And bar none, people cared about 2 things, air quality and congestion. In fact, 58% of the people surveyed had air quality as their top concern, and 53% had congestion. And those are 2 areas we can actually help with. And so the first question then being, how can we help measure air quality? And about a year ago, we did a study with EDF, the Environmental Defense Fund, where we thought, can we use fleets? Can we equip fleets? Because we have this rich, open ecosystem, the IOX port that can collect data, and there's actually a sample out in the hallway there of an air quality sensor. Can we have sensors on wheels? Is that a better option than having stationary sensors in a city? And how would that work? And Ed has already thrown out statistics this morning about the seriousness of air quality. So the question from EDF and the question for the study was, can we measure air quality using sensors on wheels? But if we're going to do that, how do we know which fleets are best suited to integrate air quality sensors? And so the first thing we had to do was we had to come up with some kind of definition of coverage. And what we did was we broke the Earth down into tiny little boxes, and we said, how many boxes can we cover in a particular city? And we'll take that percentage and we'll call it coverage. Now, there are places like lakes and parks where no vehicle is really going to be driving, so we're never going to get 100%. But can we do better than stationary sensors, and can we then augment with stationary sensors in these locations? And what we discovered was not only are vehicles a good choice and well-suited, but of all the different kinds of fleets we have, we talked to some municipalities and looked at their fleets, and what we found was municipalities, because of the diversity of what they do, actually have better coverage than commercial fleets, top commercial fleets in those areas. And this is a really, really good thing, because there's incentive for a municipality or a city to deploy air quality sensors. And they have, as I say, they have a wide variety of uses. So they have parks departments and roads departments, and they're getting into the corners of our city just doing their daily job. And of course, a city has a direct link to environmental sustainability. So they make excellent candidates to try something like this. And so we came up with an application, and we demoed it, and we tried it. And what this is really using big data to evaluate, given a municipal fleet, what kind of coverage could we get? So this is Washington, D.C., and we're running an analysis from October to December. And if we were to outfit 30 vehicles, we would get 50% coverage in that time frame. That's the prediction here. And if we ran a longer program, if we went back a few months, and we did 6 months of a program collecting data, we would end up with, let's see what it says. We're crunching numbers here. Again, not a fundamental change. So this is about what we're going to expect with 30 vehicles. But the cities themselves, they can decide, how many vehicles do I want to outfit? And you can see the curve down there, and we'll click on it in a second. So we have some toggles. How many times do you want to pass each road? That 65% represents 15 times going through those boxes. And so if we said, well, we only want to start with 10 vehicles outfitted, we drop to 50%. And if we slide the slider all the way up to 50 vehicles, we end up somewhere in the neighborhood of 70%. And we can show them in near real time here the prediction of what areas are going to be covered. And what we can also do is we can show fleets, give them a tool to predict what the coverage will look like. So we can run this multiple times, and we can show that, over 30 vehicles, there's a little bit of diminishing return perhaps, so maybe 30 is the sweet spot for this municipality. And they can go and they can collect data. And what this particular example, when we were talking to EDF and their partners, what they were most concerned with was, what about schools? Because schools and children are very, very important. And we can start to overlay this information, and we can drill down on schools, and we can find those schools that don't have direct air quality coverage based on our predictions, and those are opportunities for us to put in stationary sensors. And so that's what we're doing on air quality. And I just want to touch a little bit on what we can do with congestion. And this is still research and development. But in order to understand congestion, we need to understand traffic. And in order to understand traffic, we believe we need to understand what's happening at intersections. And so we actually started with something like this. So what you see on the left-hand side there is a bunch of dots that represent, again, boxes on the Earth. And at this point in time on the left, we don't know what they are. Are they roads? Are they parking lots? Are they buildings? Why is someone there? All we know is there's a collection of vehicles that do something in these locations. And so what we do is we train a model. We have members of our team go in, select data, we've built a tool, and we say, this is a road, this is not a road, or this is a road, this is a parking lot. And we classify, and then we learn, and we train, and we end up with something like this, a much better representation of what an actual road is. And now we could go out and we could use maps, and we could use OpenStreetMaps and Google Maps, but we don't necessarily need to. We can identify roads as they emerge using our data. And there's actually more under the hood here. There's 102 features that go into this model to understand what is a road and what type of road is it and what is an intersection. And we take it a step further, and we draw lines through those roads using multiple vehicles. And if people turn, then we can classify that as the core of an intersection. And we can determine what constitutes approaching an intersection and leaving an intersection. And we can turn all of this data into meaningful insights for a traffic manager. And so we're trying to work with traffic management folks. We're working with the City of New York. We've done a pilot. There's some videos out there of stuff we've done using their fleets. And we're also pushing samples of this data up to data.geotab.com, our open data portal. And what we're asking for is smart people to come and tell us, is this the right fit for traffic management? How can we reduce congestion? How can we get these Class 8 vehicles in and out of a city quicker? And so there's a whole bunch of other data sets you can find on data.geotab.com. The traffic one is a sample of Oakville. But the other thing we're doing is we're reaching out directly to smart people through Kaggle. And so we have this Kaggle contest ongoing right now with our friends at Google, and we're saying, help Geotab. We have an immense amount of data. We have figured out what an intersection is and what behaviors we have at intersections. Can you predict, using this data, what's going to happen at an intersection? Because we believe that if you can predict and if we can fundamentally understand some of the commercial vehicle behaviors in a city, then we can make efforts to improve them. And so this is ongoing, and anyone in the audience can participate. There's actually some BigQuery credits as a prize, and you can find me after if you want to chat more. But really, I'll leave you with this message, and I know it's long-winded, but all I want to get at is we have lots and lots of data, but just having data alone is not enough. And Raul touched on this earlier in his presentation. We need to be data-driven. But one of the things Neil always says to me is that we can't be all things to all people. But what we can do is we can understand our data better than anyone else. And we can activate with a team of data scientists and a team of software developers and data engineers. And so our goal is to work with customers, partners, to take this data, take these insights, and bring them to life to make the places that we work, the operations that we have more efficient, and places that we live much more safe and much more sustainable. So that's it for me. Thanks. No questions.
All right. Thank you very much, Bob.